If you haven't already heard, a team of researchers led by paleontologist Paul Sereno recently described a new species, Spinosaurus mirabilis. It was found in Niger, right in the middle of the Sahara Desert. Even though there was plenty of water around, Sereno and his colleagues don't think Mirabilis was a habitual swimmer. Instead, they describe it as being a hell heron that's stalked along river edges. Part of what makes Spinosaurus such a popular dinosaur is that it is so mysterious. We have to use our imaginations to piece together what it might have looked like and how it might have behaved. And isn't that one of the coolest things about paleontology? We're not even halfway through 2026 and it's already proving to be big. Yeah, I've got 5 breaking stories in the world of paleontology that are going to shiver your timbers. Some new sig dinosaurs, a new and very unexpected apex predator of the Cretaceous, and a reclassification of an iconic fossil that might now be considered a new form of life from a kingdom that is now entirely extinct.
I actually never thought about that. There's gotta be animals or living beings that are not fossilized or ever preserved, right? There's gotta be at least some of them.
Give you some context on the nature of the fossil record. As I have mentioned a few times on this channel, the fossil record can be muddy as fuck. It gives us a good snapshot into Earth's history, but definitely not a complete picture. Not all animals become fossilized. Matter of fact, the vast majority of animals that have ever lived left behind absolutely zero trace. It's a process that requires certain criteria to be met. So here are some tips and tricks if you want to preserve your body for millions of years. Number 1, have a hard skeleton or hard parts, bones, teeth, shells, woody tissue, etc. Soft bodies like you find on worms, jellyfish, lots of insects, decay way too fast to leave much behind. So 1, hard parts. Check.
Yeah, so again, I feel like there's a possibility that the species that we have evidence for, or even the potential to have the evidence that are still underground or somewhere on Earth, might only be a fraction of what they were back then. No? There could be organisms that we don't even know possible exists, but we just never found their footprints, remains, stuff like that.
Number 2, die in the right environment. Ideally in a drier environment and in sediment like mud, sand, volcanic ash. If you're in the United States, maybe Utah, Montana, Colorado. This goes into number 3. Get buried quickly before scavengers and decomposition get you before you even get a chance. All right, make sure you got that written down. Never know when that might come in handy someday.
Wait, decomposition? Doesn't that only affect your flesh? Wait, no. Hyenas can break bones. Is there other animals that also break bones? Maybe microorganism? I don't know.
Once you're all nice and cozy, buried far away from any form of life that can use and exploit you, the fossilization process can begin. Over thousands to millions of years, sediment keeps piling on top, and the pressure starts compressing the layers into rock. At the same time, groundwater seeps through. Minerals dissolved in that water slowly infiltrate the tiny pores inside your bones, crystallizing in place. A process called It's a little bit of a tongue twister.
Permineralization? Huh, how does that work? That's also fossilizing? Well, then how do we know what the original bone structure or what they're made of?
Permineralization. Essentially, your bone gets replaced molecule by molecule with rock. You become rock. There's other pathways too, like molds and casts, where the original material dissolves, leaves a cavity that later fills with new minerals. There's carbonization that happens a lot with leaves and soft tissues, where everything compresses into a thin carbon film. And in rare, very cool cases, preservation in amber or permafrost. Very
fun story. When I was in high school, I did a homestay in Kyushu, Japan. I went to a local landlord with noble ancestry, right? So samurais. And so they have this century-old house that was built with real wood. And there are ambers on their fucking pillar. And there was one speck of sap with a very tiny bug in it. They don't know what bug that is, but it's there. It's still on their pillar. They told me that it's very rare as well. So yeah, it's just a cool experience I had with these stuff.
Very sick, because it can lock in soft tissue, DNA fragments, even color. But again, the soft tissue fossilization is really, really rare. So the fossil record tends to be heavily skewed towards vertebrates, animals with a backbone.
That makes sense.
The hard parts.
They're also bigger.
Animals without backbones are a lot rarer in the fossil record because they fossilize like shit. Also because invertebrates are generally thought to be smaller and simpler than vertebrates. I know you bug freaks are probably offended, but you know it's true. at least a little bit. Ever since vertebrates evolved, they've been at the top of the food chain. The invertebrates, meanwhile, are usually just little guys that get eaten by bigger guys. The vertebrates. Sure, we can get into the Carboniferous period where that wasn't necessarily the case. Overall, though, I think it's fair to say that's been the case for the history of complex life in general. Invertebrates generally just go about their business and try not to get eaten in the process. But some invertebrates have taken a more active role in life. Some have grown to truly insane
giant
sizes
squids.
and have become insane predators. That's right, bitch, the cephalopods. This is the family of soft-bodied invertebrates that include octopuses, squid, nautiluses, cuttlefish, and some extinct ones like ammonites and orthocones. The giant and colossal squids alive today are great examples of invertebrates saying fuck you to the idea of being at the bottom of the food chain. Giant squid without the tentacles can reach 16 feet. Colossal squid to 14 feet. With the tentacles, they're like over 30 feet long. That's fucking crazy. That's 3 times the length of this room. That's 5 times the length of this.
And we also don't know the extent of how big they can grow, right? Because from my understanding, from almost my very first video on this channel, is that there was very little evidence that we have from these creatures. And so even the whole deep sea gigantism is unsolved. These animals are so rare that we don't even know for sure just how big they can get. So yeah.
5 times the length of that. Ugh, that's sick. Absolutely horrific. They get so big that their only natural predators are sperm whales, which are even bigger. The largest individuals get up to 52 feet. But what if I told you there were even bigger cephalopods alive in the late Cretaceous? Yeah, we've arrived at the first fossil discovery on our list. Just announced this year, a potentially 62-foot-long octopus, bitch. You know what else is 62 feet long? Dimensionofstuff.com says 2 buses, a cricket pitch, whatever the fuck that is, a bowling lane apparently. A bowling lane feels a lot shorter than 62 feet.
Sorry, I can't read freedom units. 19 fucking meters of a squid. God damn. That's gotta be rare though, right? Because they are also soft tissued, no hard bones. Wait, that's even crazier to think about. They live underwater as well. How did we find that?
AKA a very great length. And compared to living octopuses, that is gargantuan. The biggest octopus alive today is the giant Pacific octopus that we know of that can get to like 14 feet. This newly described octopus was given the scientific name Nanaimoteuthis, also nicknamed the Cretaceous Kraken in the paper, which is sick. Scientists estimate it ranged from 22 feet all the way up to 62 feet. So even at the smaller end of the scale, they were still way bigger than modern octopuses. Also, 22 to 62 is a pretty big size range. So how the fuck did they figure this out? I mentioned invertebrates don't usually fossilize all that well because they don't have the bones. So where did the authors of this paper get their evidence from? Well, an interesting thing about cephalopods is that when they first evolved all the way back in the Cambrian, they would have had shells. We know this because a bunch of them were fossilized, like the shells of ammonites, orthocones, these paperclip looking freaks. Over time, most cephalopods got rid of their shells. The only ones that kept them were the nautiloids, which is why they look prehistoric as hell. Octopuses, squid, and cuttlefish all either lost their shells or kept a small shell inside their bodies. That's what a squid pen or a cuttlebone is. Not a bone, because like...
Wait, those are shells? I didn't know that. I've accidentally, well, no, not accidentally, but like, you know, when you're just lazy and you don't want to spit that shit out, and when the squids are small enough, you kind of just swallow it. No, just me.
Like I said, this is a no-bone zone. There's plenty of reasons why cephalopods decided to get rid of or internalize their shells. Size, speed, fluidity. When you have to carry around a shell wherever you go, you're limited in how big you can get and how fast you can go. We've all seen snails. They're slow as fuck. Or how liquid you can be. It's helpful to be liquid in many scenarios. So while getting rid of their shells allowed cephalopods to get bigger and swim faster, it also meant they didn't leave behind a lot of fossils for us to find. Obviously, fossilization wasn't a priority for them, but it does make studying their evolution a bit harder. But there is one hard part of their bodies that they didn't get rid of. Their beaks. That's right, bitches. Cephalopods have beaks, and they fossilize. Scientists can use these fossilized beaks to estimate the size of the cephalopods they belong to. Kind of like how we can guess the size of megalodon based on their teeth. So, the authors of the paper, a team from Hokkaido University in Japan, used high-resolution grinding tomography, which is kind of like an advanced CT scan, and an AI model to find fossil octopus beaks hidden inside solid rock. The fossils came from sites in Japan and Canada. They were buried in calm seafloor sediments, which mean they were very well preserved. Because they were in such good condition, the Hokkaido team was able to see wear marks and scratches on the surface of the beaks. These marks are consistent with the kind of thing you'd expect to see on the beaks of modern cephalopods. They used their beaks to crush and crack open shells, which strongly suggests that the Cretaceous krakens were active carnivores that routinely crushed hard shells and the bones of large marine vertebrates in their beaks. For context, the large marine vertebrates in question of the time were things like mosasaurs, plesiosaurs, fucking horrific predators in their own right. With estimated total lengths of 62 feet, the krakens might have been the biggest predators in the Cretaceous oceans that we know of.
Wait, how? That doesn't make much sense to me. Unless they are ambushing, right? Because I feel like this giant squid or cephalopod, right? Do they really have the fighting power to go head to head with a mosasaur? I mean, plesiosaur, sure, get its neck, it's done, but mosasaur, really?
Rivaling or even outgrowing mosasaurs and other large marine reptiles. That's horrific and basically rewrites everything we thought we knew about what life would have been like for animals in the Cretaceous oceans. Mosasaurs are generally thought to have sat at the top of the food chain, but now it seems like they might have been in direct competition with fucking giant krakens. And who knows, maybe even hunted by them. Probably at least a little bit. Absolute nightmare freaks. Horrific. I'm glad we found out about them because they're sick. All right, next up on the list is
Yeah, but that's also just an estimate, no? Because isn't there a possibility of them, having a oversized beak? Kind of like the four-legged T-Rex, where just from the skull itself, it looks like another giant dinosaur that could have rivaled T-Rex or something. But when you found out the rest of it, it's simply an oversized head. I'll be honest, it's not as cool. Just want to point it out.
Next up on the list is another horrific animal from the Cretaceous. One you're probably already familiar with, but surprise, surprise, another fucking big update. Yeah, new Spinosaurus shit. If you haven't heard, a team of researchers led by paleontologist Paul Sereno recently described a new species, Spinosaurus mirabilis. But before we get into it, let's get on the same page about Spinosaurus. Even if you don't know that much about dinosaurs, there's certain names that pretty much everyone knows. Ask any 10-year-old, 4 out of 5 of them would probably be able to name it. But Spinosaurus hasn't always been so famous, despite its iconic look with its long, crocodile-like snout, massive size, and big-ass dorsal sail. A lot of what we think we know about Spinosaurus is actually just clever guesswork. Let me explain. In the early 20th century, excavations by various different teams uncovered some unusual fossils in North Africa. Nobody knew what animal they might have belonged to until 1915, when German paleontologist Ernst Stromer named and described a new dinosaur species, Spinosaurus Egyptiacus. Hold on. Spinosaurus Egyptiacus. The type specimen, which is usually the first fossil to be discovered that's then used as a reference for all future fossil discoveries in a certain genus, was pretty shit preserved and consisted of only fragmented remains. Among these remains were parts of the jaw, the neck, ribs, teeth, and tail. But the thing that earned Spinosaurus its name were its dorsal neural spines. Unfortunately, the Spinosaurus fossils didn't get much attention at the time, possibly because it was 1915 and everybody had more pressing issues to worry about. Many years later, in 1936, the Spinosaurus fossils were put on display in the Paleontological Museum of Munich. Then, in 1944, the world was at war again, and the museum was bombed during a British bombing raid. The Spinosaurus fossils were blown to bits, which you would think would be the end of Spinosaurus. But no. In 1983, a new dinosaur was discovered in Surrey, England. Not a Spinosaurus, but a Spinosaurid, meaning it was in the same family of dinosaurs, but not in the same genus. Family, genus, species. It was named Baryonyx, and unlike the fragmentary Spinosaurus Egyptiacus, it was mostly complete. Since Baryonyx was part of the Spinosaurid family, this allowed researchers to piece together what it and other Spinosaurids might have looked like. Baryonyx was smaller and didn't have the dorsal sail that characterized Spinosaurus, but the two did have a lot in common. They both had big-ass heads and teeth that looked very reminiscent of crocodiles, which immediately made the researchers think the Spinosaurids were semi-aquatic, or at least adapted to eating fish. But Baryonyx didn't have a body plan that was very well suited to swimming or hunting in the water. Looked pretty much like a standard terrestrial theropod dinosaur with a weird crocodile head stuck on top. That is like the simplest way to put it, by the way, but I'm just gonna keep it simple. Then in the late 1990s, another Spinosaurid, Suchomimus, which means crocodile mimic, was discovered, which was pretty similar to Baryonyx. Based on the limited evidence, researchers could only assume all Spinosaurids had a standard theropod body plan. There was still a lot of debate about whether Spinosaurus Egyptiacus could have been more adapted to aquatic lifestyles than Baryonyx and Suchomimus Suchomimus. But since there were no more fossils, it was impossible to say for sure. It wasn't until 2014 that we got a new type specimen for Egyptiacus. And this is when the controversy about Spinosaurus really took off. The authors of this paper noted that the back legs of the new Spinosaurus specimen were quite a lot shorter than the previous reconstructions had made them seem. Researchers had used baryonyx and Suchomimus to model what other Spinosaurs might have looked like. They might have had a pretty standard theropod body plan, with long back legs for running around on land, but Spinosaurus definitely did not. This led the authors to speculate that Spinosaurus could have been a quadruped walking around on 4 legs.
I mean, a quadruped would make much more sense as an aquatic animal, wouldn't it? It also provides more stability. I feel like that reinforces it.
Or that it was semi-aquatic and used its back legs for swimming. That's why you sometimes see reconstructions of Spinosaurus that look like this, which show it having short legs, ending in webbed feet, and a long eel-like tail. There's also some more heinous depictions of Spinosaurus that imagine what it would have looked like if it was fully aquatic, which make it look like some sort of freak-ass elephant seal, something like an ichthyosaur, maybe an early whale. Just feels like throwing shit out there. Of course, some new evidence has come out that basically says, although Spinosaurus did hang out in the water and did eat fish, it probably wasn't aquatic. In February 2026,
Wait, what?
Yes, this year, a team led by paleontologist Paul Sereno dropped a bombshell paper revealing they had discovered a new species of Spinosaurus. Spinosaurus mirabilis, as I said. It was found in Niger, right in the middle of the Sahara Desert. Today, the Sahara is one of the driest places on Earth, but in the late Cretaceous, when Mirabilis was alive, it would have been a forested wetland ecosystem that could support several giant dinosaurs. Even though there was plenty of water around, Sereno and his colleagues don't think Mirabilis was a habitual swimmer. Instead, they describe it as being a hell heron that stalked along river edges. Sereno argues that even though Mirabilis did have short legs, just like the Spinosaurus Egyptiacus neotype, it was still a massive animal, and its legs would have been incredibly strong and sturdy. This would have allowed it to wade in the shallows of large rivers to hunt for fish.
Oh,
Even
yeah.
6 feet of water would have been like stepping in a puddle for a full-grown Spinosaurus.
And also with its massive head, they can pretty much just pick out fish however they want, right? So they don't necessarily need to swim. They might have just hang out, like they said, in the water. And that makes sense. But what are the spines for? That's the question that I always had.
And that's not even the coolest thing about it. Not only did Mirabilis have the iconic sail on its back, it also had a huge scimitar-shaped crest on its head, which probably would have made it one of the most standout animals in the late Cretaceous that we know of. It was also covered in a thick layer of keratin, kind of like a cow horn, which would have made it look even longer and sharper when the animal was alive. Pretty fucking gnarly. This new discovery helps us understand a lot more about the Spinosaurus family, including whether or not they were aquatic. From what Sereno and his co-authors say, it seems like Spinosaurus was more of a wader than a swimmer, which is still very cool. But there's still plenty that we don't know. One big thing is we don't know exactly how big Mirabilis might have gotten. The specimen they found is a juvenile. It was about 26 feet long when it died, but it wasn't fully grown.
Pretty fucking
Seems likely
huge.
that it could have been much bigger as an adult. Part of what makes Spinosaurus such a popular dinosaur is that it is so mysterious. We have to use our imaginations to piece together what it might have looked like and how it might have behaved. And isn't that one of the coolest things about paleontology?
But then also, yeah, like she said, that's a lot of guesswork, right? Because even species in the same family can look massively different than each other, right? So wouldn't that mean there's a possibility of, you know, both of these records, whether it's from the 1915 or it's from the early 2000s or the new one that we have in 2026 might all be correct? You know what I mean?
Moving on, because that's not the only cool new dinosaur discovery on the list. Back in March 2026, this year, scientists announced that a rare dinosaur fossil was found in South Korea. And it's cute as fuck. The fossil is considered very rare because not many dinosaurs have been found in South Korea. Matter of fact, until the new discovery, only 2 Korean dinosaur species had ever been reported on. Both of those are only known from postcranial remains, which means no skulls were found. There were definitely plenty of dinosaurs living there because Korea has a lot of fossilized footprints and eggshells, but for some reason the skeletons are just particularly hard to come by. It's thought that in the mid-Cretaceous, when this new Korean dinosaur species was alive, Korea was made up of a lot of tidal mudflats. That meant dinosaurs who were walking through the mud were more likely to leave footprints behind. But it also meant the dinosaur remains probably got washed out to sea before they could fossilize. This new species is actually the first to have been found in South Korea in 15 years. So it's a big fucking deal. And the researchers who made the discovery decided to name the new species Doolysaurus, after a South Korean cartoon dinosaur called Dooly. Very cute. One of the cool things about Dooly is how well preserved it is. Not only did they find the postcranial skeleton, but they found its skull as well. Dooly was almost fully encased in solid rock, which means its bones are all still in their original place, instead of being spread out fucking all over the place and fragmented. This gives a much clearer view of what Dooly would have looked like when it was alive. Like the Spinosaurus mirabilis type specimen, Dooly wasn't fully grown. Based on growth markers in its bones, Dooly was probably no more than 2 years old when it died. The researchers who discovered it also think that it would have been covered in a thick layer of fluffy feathers, kind of like a baby bird. It was estimated to be about 18 pounds, but adult Doolysaurus might have grown to twice the size. Still, compared to a lot of dinosaurs that were around in the Cretaceous, Doolysaurus would have been pretty small. Dooly was a kind of dinosaur known as a Neornithischian, but it was one of the earlier, more basal species in the group. Later Neornithischians included ceratopsians, like my personal favorite, Diabloceratops, also pachycephalosaurids and hadrosaurs or duck-billed dinosaurs. Doolysaurus is thought to be somewhere near the base of this dinosaur family tree. During a time—
How do we know if they have feathers on their skin? How do we know that? Because we don't have the skin. You can't find a feather. And how do we know what dinosaurs are feathered and what's more, traditionally reptile-like? You know what I mean?
Time when the fancy shit of this lineage didn't evolve yet. So they were still just little guys. Speaking of little guys, feast your eyes on this little fucking freak face.
It looks like a
little
toad.
Son of a bitch. Gotta figure out how that's pronounced. Tyrannoroter Herberti. And it's thought to be one of the earliest land vertebrates to eat plants. I know it's kind of thought that, at least this is how my brain works, that plant eaters are the primitive shit. They're the baseline. And then some animals started to eat other animals, and then carnivores existed. But no. It's the opposite way around. There were land vertebrates eating other vertebrates and other animals before there were land vertebrates eating plants. I also don't want its badass name to deceive you. Tyrannoroter was no bigger than a fucking football. You could punt him right into next Tuesday. It was part of a group of early tetrapods called the microsaurs, which lived during the late Carboniferous and early
little
Perm.
lizard.
They looked like little fucking footballs. Thick head, short tail, stubby little legs. Worth mentioning, even though they kind of looked like lizards, they weren't lizards. Lizards didn't even exist back then. Tyrannoroter was alive 307 million years ago. That's before lizards. Tyrannoroter and other—
Yeah, I feel like there's not really a way for at least people like me who are, pretty uneducated, let's be honest, in these type of stuff, is that we look at things with the lens that we understand. When I see a dinosaur, I see a reptile skin, I associate them with the modern reptiles, even though, in this case, they predate the fucking lizards. But in our head, there's not a way to actually name them or to describe them. You know what I mean? Also, the bird that we understand right now are living dinosaurs, not crocs, not lizards, none of that. The reptile-like dinosaurs all died. My point is that I feel like that's part of why there are so many conflicting, even descriptions, based on your level of understanding in paleontology or the entire dinosaur, prehistoric, whatever stuff. The way you describe these animals would be completely different, even when you're trying to describe the same fucking thing. So yeah, it is a bit confusing.
Microsaurs might have actually not been closely related to any living class of animals. Some scientists think they might be related to modern salamanders, but not entirely sure. They might have just been their own class, doing their own thing, leaving no descendants behind, which is pretty crazy to think about. Tyrannoroter is estimated to be about a foot long. Also had a snout that looks like it was adapted for digging, which makes the team that discovered it think Tyrannoroter was a burrower. I probably would be too if I was just a little guy living in the Carboniferous with all those big ass bugs around. They probably would have tried to use me for sport. Scientists suspected for a while that herbivorous tetrapods must have evolved in the Carboniferous, because by the time the Permian rolled around, the dynamic of land-based carnivores and herbivores was already pretty well established. There were predators like Dimetrodon, Dimetrodon, and Gorgonop. And there were plant eaters like Listersaurus and Edaphosaurus. So since that dynamic predator-prey dynamic—
Ew! It looks like a mutant from Stalker. What the hell? Yeah, the bottom one looks like if you skin a sea lion, it would be what it looks like. Well, with legs and a tail, right? But how do we know what color they are when all we had is their bone, teeth,
Mimic already existed, it made sense that it emerged in the previous period, the Carboniferous. But no evidence had been found of early VeggieTales until Tyrannoroter came along. Tyrannoroter was found by an amateur paleontologist, Brian Herbert, who had been searching for fossils on Cape Breton Island in Nova Scotia for hours before he stumbled upon a fossilized tree stump. But that wasn't all. Sticking out of this tree stump was the fossilized skull of a small lizard-looking animal. He immediately realized he found something new, so the research team that analyzed the fossil named the species Tyrannoroter herberti. Tyrannoroter herberti. So I said it wrong before. I said Heberti because I misspelled it in the script. It's Herberti. The really interesting thing about Tyrannoroter is that when the research team did a CT scan of its skull, they discovered that its mouth was full of 36 teeth, as well as these weird grinding structures called dental batteries. Turns out these are some pretty complex structures. They're essentially formed of hundreds of teeth that are stacked on top of each other in rows. Together, they create a tough grinding surface that would have helped with chewing fibrous plants. These dental batteries also existed in certain plant-eating dinosaurs, like the duckbills and the long-necked sauropods. That strongly suggests Tyrannoroter was also a plant eater. But here's the thing. Dental batteries would have taken millions of years to evolve. So even though Tyrannoroter is the earliest herbivorous tetrapod that we currently know of, it definitely wasn't the first. Herbivory must have been developing in other land animals for a long time. That's why Tyrannoroter was so well adapted to eating plants. So not the first, just the earliest that we know of. All right. I saved the best for last. Within the eukaryote domain, there are 4 kingdoms. So domain, kingdoms, and then other things. The 4 kingdoms are fungi, plants, animals, and protists. But scientists might have just discovered a new type of eukaryote, which would potentially make it 5 kingdoms. That's a big fucking deal. It's an even bigger deal because some of you might have heard of Prototaxites before. I really fuck with them. I've talked about them a lot. They were some of the largest organisms on land during the Devonian period, like 420 to 375 million years ago. They looked like huge branchless tree trunks. They got to like 26 feet tall, and there were no trees at the time. So these were like the trees of the time. All the plants that were growing on land at the time were pretty small and unimpressive. So these giant towers acted kind of like trees. There's been these little tracks found inside of them, probably from little millipedes and worms, like using them for shelter and shit. And what's crazy is because they were 26 feet tall, nothing else was 26 feet tall or even close to that. So they just towered over everything else on land. Walking around on land would have looked like walking on an alien planet.
Yeah, I was gonna say, it would look alien-like. Wait, how did we find these? They're just pillars on the ground. Like, what?
Since the first fossils of Prototaxites were discovered way back in 1843,
what are they made
scientists
of?
have been arguing about what the fuck they actually were. Were they a type of algae, a plant, a fungus? The debate has been going on for over 165 years and nobody could agree. But for a while, the leading theory was that they were a type of fungus. That's what I've always introduced them as, because they have these tubes running through their insides, kind of like the internal structure you'd see in fungi. In 2007, a study of their carbon isotopes seemed to support this. But a paper published in January of this year, 2026, has raised an interesting possibility that Prototaxites was none of those things and that it was a totally different form of life, one that we never knew existed. And the National Museum of Scotland examined fossils of a Prototaxites species called Prototaxites tidy that was found on the eastern coast of Scotland. The team found that even though Prototaxites had those fungi-like tubes inside them, the way those tubes were structured was completely unlike anything seen in any known fungus, living or extinct. Instead of the orderly branching system you'd expect, there were these weird, chaotic 3-dimensional networks. There were also distinctive dark circular blobs running through the body of Prototaxites. They called them medullary spots and noted that no known fungal group has anything like them. The team also did a chemical analysis of the fossil, and that had even more surprising results. Buried in the same rock formation as Prototaxites were some ancient fungus fossils. These fungi were the same age as Prototaxites, but they had very clear chemical signatures associated with chitin, which is basically the main building block of fungal cell walls.
Ooh, yeah, that actually supports it. Because at first I was like, it could have just been an early version of type of fungus, right? Knowing that actually makes a huge difference.
Prototaxites had none of that. A specific fungal biomarker chemical wasn't found in Prototaxites either, even though it showed up in the surrounding fossils just fine. So it seems like Prototaxites was not a fungus. It was not a plant. It definitely wasn't an animal. And it probably wasn't a protist either. The researchers think it was something else entirely. A completely extinct branch of complex life that has no living relatives today, which means that at some point in Earth's history, there was a whole kingdom of life that lived, grew, gargantuan, dominated entire landscapes, and then vanished completely, leaving behind nothing but these mysterious stone columns and a very long-running scientific argument. That is one of the most insane things I've ever said. And, of course, just makes me want to know what else is out there, buried in the rock, waiting to completely rewrite the story of life on Earth. Because that's just fucking crazy, dude.
Damn, yeah, again, knowing that there might have not been just 5, there could have been more that we will never know existed. That is such a shame. Like, I'd like to know all of them. I don't know. I feel like it feeds into this curiosity. It's almost like going on an adventure with your mind, where you can imagine in your head what it would be like around these animals, what it would be like back then, you know, the environments, landscape. It feels like an adventure in your mind. I mean, at least for me. But anyways, the link to the original video will be down in the description. I hope you enjoyed the video. I'll see you next time.